Yes, okay, you can see this already. All right. So this is the same promotion. Just a reminder, continue to share with your friends and family. All right, let's start with the first question. Okay, let me check the thing. All right. Okay. Now over here, you want to increase the temperature. By the way, I must tell you, boys and girls, I have a question there. I don't have any responses for this tutorial. So I'm just curious, is it because you're too busy to do this tutorial, this worksheet 32, or is it because you cannot access it in the learning portal? Because usually I will download, Arjun, you did it, but I downloaded the Excel file. There's no response, zero. A few minutes ago, I was having a class. I have another tutorial class before this. Okay, no wonder. Zixuan, you did it a few moments ago. If you all just did it a few moments ago, then there's no way for me to download. Actually, I downloaded last night. And then thinking that maybe you are really busy, maybe you all did it this afternoon. So I also downloaded this afternoon before about 5 o'clock. All right. So yeah, so never mind, no worries. Okay, some of you submitted, at least you have tried. But then how many of you have not even seen the question? Can you type into the chat, please? Not seen the question. I mean, be honest, it's okay, no worries. How many of you have not seen the questions at all? Anyone not seen at all? Just type me if you're not seen at all. Anyone? Okay, so you have read the question, am I? Right? So we will start. So over here, to increase the temperature of 1 kilogram of copper by 1 degree Celsius, you need 400 joules of heat. Okay, so now they are saying 12,000 joules of heat is supplied to, all right, 2 kg of copper. All right, so at least I know it's the same material, copper, at the initial temperature of 25 degrees Celsius. What is the final temperature, all right, of the copper? Okay, so this is actually like doing maths. So some of you are so strong in maths. Okay, so since you're strong in maths, I'm going to ask another question. Can you write the symbol of copper in the chat? Let's see whether anybody got it wrong. Write the symbol of copper, chemical symbol of copper in the chat. Okay, well done, Arjun. The rest? I have 6 students. I have 6 responses. What is a chemical symbol of copper? The rest cannot remember, right? IDK, so at least I won't be waiting. All right, thank you, Kiran. Well done. Cannot remember, right? IDK. Well done, Sheena. Except Sheena, you must have a capital for the first letter. All right. So good job, Zixuan. All right. So capital C, small letter U. Right, see you. It sounds like see you, right? See you next week. Okay, it sounds like see you. Okay, so anyway, back to this physics question. All right. Now, if you want to increase 1 kilogram, all right, by 1 degree Celsius, you need 400 joules of heat. Therefore, if I want to increase 2 kg of that copper, I will obviously need 800 joules of heat, right? It's actually 2 over 1 times 400. Right, so you will need 800 joules of heat to bring it up by 1 degree Celsius. All right, if you want to bring it up by 1 degree Celsius. Okay. Right, so this is the first part. So now is I write the other way around. I draw a line across. So I know 800 joules of energy. 800 joules, yeah, of heat energy. All right, will bring up the temperature by 1 degree Celsius. Now I have 12,000 joules of heat. All right, so I usually teach students, even no matter how weak you are in mathematics, is bottom number divided by the top number times the other side. So this would be, can you all help me type, is it 15 degrees Celsius? Yeah, press your calculator. Thank you, Arjun. All right, I don't have a calculator with me. I was using my handphone just now. All right, of course I have prepare it in advance, all right? But usually I want to write it instead of typing for this. Therefore, the third last step will be the final temperature, right? Will be the initial temperature plus the increase. This one is increased by 15 degrees Celsius. Therefore, your answer would be 40 degrees Celsius. So answer is D. All right, is this easy? Okay, good job, Arjun. You can see all your steps very clearly. All right, so these are the first step. Step 1, step 2, and step 3. I mean, if your brain is fast, you want to combine all 3 steps into one step, that's fine, as long as you get the answer. Okay, because it's MCQ. But if this is an open-ended question, you have to make it neater. So always remember, you will check the mass of the material. So if they give you 1 kg and then the question is changed now to 2 kg, you need to make sure it's the same mass. Change it to the same mass. All right, so change a 1 kg to 2 kg. So times 2 here will be times 2. So 400 joules change to 800 joules. So 800 joules of heat energy is required to bring up the temperature by 1 degree Celsius. So times 2 here, times 2 here. So that you can compare the same mass, 2 kg with 2 kg. All right, any questions so far? All right. Okay, question 2. As a space shuttle, sometimes I always wonder, how many of you will have the courage to sit inside a space shuttle? Anybody, if I give you the chance to go into a space shuttle, to go out to the outer space, how many of you will take the chance? How many of you will not take the chance? Okay, Aaron say me. How many of you will take the chance? Arjun says, yes, only if the magic school bus teacher is there. Is it because why? But what's so fantastic about magic school bus, Arjun? Magic school bus teacher can what, save your life? If anything happens, is that what you mean? Or can string you or can explain to you? Tina say no thanks. Arjun said the magic school bus teacher is very smart, will ensure everyone's safety. You know, nowadays aeroplane also can have aeroplane crash, right? But no matter what you do, sitting on the toilet bowl, you can even die. There was someone in another country was sitting on a toilet bowl, and then the plane crashed into the toilet. So don't need to leave the house. That person passed away. The person died because there was a aeroplane crash that crashed into his toilet, which is very sad, lah, poor thing. All right, I can only say rest in peace. No choice. All right, so yeah, and if given the chance, I would love to take the chance, but I also be like praying hard to whatever God you believe in to make sure it's a safe journey because anything can go wrong. But even staying in the house, anything can also go wrong. When it's time to go, it's time to go. Right, next. Right, so space shuttle is at the space rocket enter the Earth's atmosphere. That is the most dangerous part. All right, when they are about from outer space, when there's very little air, almost a vacuum, where it's not really a vacuum, very little air there. In order for it to enter the Earth's atmosphere means the air, it is the most dangerous part. Okay, because the rocket will get very hot, intensely hot. So if there's any problem with your rocket, the rocket material must really be the good choice. You don't choose the wrong material for your to build your rocket. You know, like the submarine, or we call it submersible, they use the wrong material to build the submersible. So the submersible is going deep in the ocean. The submersible material cannot put the weight under the ocean, deep in the ocean. They use the wrong material. So up in the air, you also need to make sure you use the right material because your rocket is going to get very, very hot. So the underside of the space shuttle, is covered with this material called silicon dioxide. Now everybody type into the chat, what is the formula of silicon dioxide? Type into the chat. I always like to give extra questions so that we revise other topics as well. So what is the formula of silicon dioxide? Silicon is Si. I help you with this. Oxygen is O. So what is the formula? Okay, good job, Arjun. The rest, silicon dioxide. Di means how many? Okay, di is like you have mono. Mono means 1. Di means 2. Tri means 3. Okay, so di means 2. Therefore, the formula is Si capital O2. All right, SiO2. That means 1 Si, 2 O2. but we usually will just write without the 1. Okay, so silicon dioxide is like carbon dioxide. Carbon dioxide is this, so this is silicon dioxide. So dioxide. Di means 2. Right, it's like bicycle. Bicycle, B-I means 2, got 2 wheels. Instead of tricycle, it's a bicycle. So in chemistry, Bi and Di means 2. All right. So which property should the silicon dioxide tiles have? All right. Now brittle means it will break easily, right? That's bad, right? Okay, glass is brittle. Okay, so that's bad. I don't want it to be brittle. I don't want my space rocket to break. All right. Is it important for your space shuttle rocket to be transparent? Is it important? Not really, right? I don't care. It doesn't matter whether it's transparent or not. All right. So high melting point is important. High melting point, the meaning of that means it needs a high temperature. This is the meaning. It needs a high temperature. You need to heat it up until the temperature becomes so high to melt it. Need a high temperature to melt. So in other words, very hard to melt lah. All right. So I write inverted comma, very hard to melt. But don't write this, don't write very hard to melt. You write needs a high temperature to melt it. So that is good. I need it. I don't want my space shuttle to melt it. All right. Good job, Harjun. Will not melt and burn the spaceship. All right. Then I also need it to be a good heat insulator. Out in outer space, you're nearer to the sun. All right, so that the heat will not reach the inside because I'm sitting inside the space shuttle. I don't want the heat to come to me. I don't want to feel the heat. I'm nearer to the sun, you know. So I want it to be a good heat insulator. That means heat does not pass through it easily. All right, so that is the meaning. Okay, heat does not pass through the material easily. Now, another word for it means it will gain heat faster or slower. And y'all type into the chat. Thank you, Arjun. And the rest, I need response. Please cannot always be Arjun. All right, I also want other names. Okay, Arjun, keep it up. But the rest, I want other names. So gain heat faster or gain heat slower? If you are a good heat insulator, let me write here. Good heat insulator is equals to opposite of good is poor. Opposite of insulator is, do y'all know what is the opposite word of insulator? What is the opposite word of insulator? Starting with C. Conductor. This part, please remember, please know. So I'm going to write here, opposite of good is poor or bad lah. Okay. Opposite word of insulator is conductor. Okay. So when you have things that is called poor heat conductor, that means it will gain heat slower. All right. Some of you have the wrong concept, as well as lose heat slower. Everything slower. Then how do I know whether gain heat or slow heat? It depends on the context of the question. In some context, it will gain heat. In some context, it will lose heat, depending on the situation of the question. But it will always be slower. All right. So this part is important. It must be slower if it's poor. All right. So I teach you how to remember. You always look at the word conductor. If it's poor conductor, think of it as a poor runner. If you're a poor runner, imagine you're a marathon runner. You're a poor runner, your speed will be slower, right? Okay. So good job, Kiran. Good job, Arjun. You can see the word conductor. All right. So don't go and see this word good. Then you tell me, oh, good runner means I will say good runner. If I'm a good runner, my speed will be faster. Then you talk faster, which is wrong. So always consider the word conductor. So a good heat insulator is equals to the same meaning as being a poor heat conductor. All right. So this material is a good heat insulator. It means this material